All right, so welcome to part 6. We have multiplied rational expressions. We've divided polynomials so that they kind of turn into rational expressions, and then we have to deal with them. We've simplified rational expressions, and now we are going to add and subtract rational expressions. Now, just like with regular fractions, rational expressions are actually harder to add and subtract than they are to multiply and divide. That doesn't mean they're impossible. That just means you have to remember common denominators and stuff like that. So what do we do when we have to do it? Well, just like fractions, we always ask, do these expressions have a common denominator? And then we really hope that they do, because it makes our life so much easier. It's all right, get through it. All right, so these two, as you're looking here, let me get my annotator going, All right, these two have a common denominator. Hallelujah. Look at that, common denominator. Okay, so all we have to worry about is adding our numerators. So 5n plus 15, they're not like terms, so they just get turned into the polynomial 5n plus 15. And on the bottom we have n plus 3. We're not quite done yet, however. We still do have to factor to check to make sure that we don't simplify something. So in this case, you factor out a 5. There it is, there's your 5. Factor it out, and you're left with n plus 3. And look at that, n plus 3 over n plus 3. They go away, and the answer to this whole thing that started out looking crazy is just 5. Okay? Yeah, this game does seem too easy. That's because when the denominators are the same, it's pretty easy. In fact, sometimes you don't even have to factor and cancel. Like you have a big long polynomial on top and a polynomial on the bottom, and la-di-da, there you go. But in this case, it's very easy, nothing to fret about. Okay, yay, adding fractions. 1/2 plus 2/2, that was always easy, right? So, all right, same thing with polynomial denominators. All right, let's practice a couple. And again, see the banner at the top here saying, do not forget, switch signs when subtracting, okay? We're not gonna forget to do that. So, n plus 4, n plus 4. Sweet. What do I mean by switch signs when subtracting? Well, I mean that this whole thing is of course going to have the denominator n plus 4, but that this whole polynomial is being subtracted. So you probably heard me say change signs and combine a lot in the last video. The same thing applies. This is minus 4m and minus 2, minus 4m and minus 2. If you leave this as minus 4m plus 2, you're gonna get it wrong. Okay, so do not forget, sometimes we say distribute that negative. I say, change your signs and combine, which is really distributing your negative over that expression. So what you really have is you have 3m minus 5, distribute that negative, minus 4m, distribute minus 2. Cool. All right, well, that simplifies into our denominator staying the same, m plus 4, and 3m minus 4m is negative m, and negative 5 and negative 2 is minus 7. And we're done. All right, going over here. Yay, we have a 3 plus y on the bottom, so we can keep our 3 plus y on the bottom. And then our numerator is 3 plus y squared. Okay. I know, right? Aren't you just dying to try to cancel something? Don't you just really want to cancel it so it turns into y? Yeah, don't. 3 plus y squared is not factorable. It's not a difference of squares. It's just 3 plus y squared. I mean, it's honestly more appropriately written y squared plus 3 over y plus 3. You can't cancel it. Y plus 3 isn't a factor of that. There's nothing you can do. This is as simple as it gets, and that's as simple as it gets, and you cannot cancel. Resist the urge to cancel. This is your answer, and that's how it's got to stay. I know. All right, that's why I put that in there, because I know it's so tempting to start chopping off 3's and canceling out y's, and you just can't. You can't. All right, so let's move on, because You know those denominators are not going to stay the same forever. We got to grow up sometime. All right, here we go. Oh, slightly different denominators. Okay, now what do I mean when I say inverse denominators? I mean, look at these two denominators. This is kind of like a wall of text, so I'm going to break it down for you. Looking first at the original problem in blue here. All right, look at this, n minus 4, 4 minus n. They're opposites. Well, we talked about what we can do with opposites, though. There is a thing we can do. Remember, 4 minus n, if we factor out a negative 1, we can turn that into this. Factor out that negative 1. That turns this into negative 4, because negative 1 times negative 4 is positive 4. Factor out a negative 1 out of a negative n, and you get a positive n. And then you just rearrange these two terms, and you have negative 1 times n minus 4. And voila, n minus 4. Yay, that's what we wanted to begin with. Okay, that's how that works. So we're going to turn it into this. I'm going to stop looking at the blue block now. We're going to change my color to pink. We're going to turn this into, and remember we don't write our 1, this term staying the same, 3n over n minus 4, plus 6n over negative n minus 4. That's still not exactly the same, is it? Negative n minus 4 and n minus 4 are not the same number, not the same expression. However, we also have this nifty little thing that we can do here in this section where we take this, we take this number here and we turn it into subtraction. Wait, how can we do that? The same reason that you can say negative 1 over x is the same thing as 1 over negative x, right? That's the exact same thing. Well, it's also the same thing as negative 1 over x. And negative 1 over x is really what we've got here. This is just, sure, the negative sign's down here in the denominator, but it's an equivalent expression to just saying the negation of this entire expression. So instead of having a plus sign here, right, instead of having this plus sign, it's now a minus sign because we've taken that negative sign and we've put it over there. Okay, you're allowed to do this. Totally, math says. All right, so now I've got a lot of gobbledygook on the screen, so I'm going to clear, and we're going to look at just what I want to look at here. All right, this expression has turned into something that has a common denominator now. Okay, so keep your eyes peeled for those opposites. 3n over n minus 4 minus 6n over n minus 4. N minus 4 becomes our nice denominator, right? And then 3n minus 6n is negative 3n, and that's your answer. Happy. Okay, so one more time. When you see opposites, you can rewrite this as negative n minus 4, and then you can just move that sign up so that the plus sign becomes a minus sign. Okay, just move it up so it's a minus sign. All right, clear all drawings. Okie dokie. And it gets more complicated. Here we go. All right, so the question is, what about when the denominators aren't alike? Just like when you had fractions, you have to find a common denominator. And when you find a common denominator, you find the LCM. LCM, lowest common multiple. Let's do a quick review of what the heck an LCM is, because some of you are going, oh, crud, I have not seen this since 5th grade. Okay, an LCM is basically if you have two multiples, let's say we have 4, 8, 12, 16, 20, 24. Okay, well, there's 4s. Let's do 6s. 6, 12, 18, 24. They have a couple of multiples in common, don't they? Right? These are multiples of 4 times 2 times 3 times 4 times 5 times 6, right? So they both have a 12 and they both have a 24. Cool. So our lowest common multiple is the number that they both fit into. They both have to fit into that number. okay? 6 has to go into it, and so does 4, and you want the lowest one for obvious reasons. All right, so what does that look like on like a break down the number sense? Well, 4s are really just powers of 2, right? So if this is 2 squared, this is 2 to the third, all right? And now we've got, ooh, we've got more stuff going on here. This is 4 times 3, right? So it's 2 squared times 3, okay? And then this is 4th, and then 20 has a 5 in it, so it's 2 squared times 5. All right, let's look at what 6 is. 6 is 2 times 3. Oh, we're here, 2 squared times 3. All right, I want you to just sort of think. 4 is the same as 2 squared. 6 is the same as 2 times 3. Their lowest common multiple is 12, which is 2 squared times 3. Notice that that 2 squared times 3 encompasses what the 4 needs to fit into that number. The 4 needs at least 2 2s to fit in there, and the 6 needs only 1 2 and a 3. So here's its 3, and it can use one of these 2s here. It fits inside. So both of these numbers have to fit inside the lowest common multiple. It has to have enough 2s to accommodate a 4, and it has to have a 2 and a 3 to accommodate a 6. Okay, so this is sort of breaking down like in real, just concrete constants, what we're going to do with algebraic expressions. Okay, so let's look. All right, we're going to find the LCM. So the lowest common multiple of 6x and 4x cubed. Okay, now when I did multiples of 6 and 4, we just counted by 6s and counted by 4s at first, right? Well, we're not going to count by 4x cubeds first and count by 6x's. That's bonkers, right? We're just going to break them down the way I did the other numbers. The prime factors of 6x are 2 times 3 times x, right? The prime factors of this, 4x cubed, are 2 times 2 times x times x times x. Okay, there are your prime factors. We have to have a number that has enough x's for 4x cubed, all right? So how many x's does 4x cubed need? Well, it needs 3 x's, all right? This one only needs 1, but that's okay. We don't care about it. It gets covered by these 3 x's, so we need 3 x's. We use the largest amount of x's we have, and there they are, the 3 x's. A 6 needs only 1 2. A 4 needs 2 of them. Okay, so we need 2 2s, right? There are the 2 2s we need. 2 2s, haha. And then the 6 needs a 3. This one doesn't, but that's okay. We still need to put it into our final answer because otherwise it won't be a multiple of 6x, okay? It won't be able to include a 6 if it doesn't have a 3 in it. So it has at least 1 3, at least 2 2s, and at least 3 x's, okay? So that turns out to 12x cubed, okay? That's gonna be your common denominator. So it's really powerful to be able to break down these denominators, look at what the components are of each one, and assemble an LCM out of the parts, the biggest parts out of both of them, okay? All right, let's move on and give this a shot in practice. All right, white space. All right, let's look at this in terms of polynomials. All right, so what's the LCM of n squared plus 5n plus 4 and n plus 1 squared? Ooh. Suddenly, we're not in Kansas. We have to think about how we factor these. Now, n plus 1 squared, that's nice, right? That's already factored. N plus 1 times n plus 1. Here, you're going to actually have to break out your diamond or whatever you call it, your X game, and think about it, right? Multiplies to 4, adds to 5. Oh, it's 4 and 1. Cool. So we have n plus 4 and n plus 1. All right. So we need to find the LCM of n plus 4 times n plus 1 and n plus 1 times n plus 1. Just like if these were like regular numbers, you need to start thinking of this as a number. It is a factor. Okay, you're not trying to think about what's inside it, and plus, like n plus 1 is 1 unit. It is 1 factor. Okay, so we look for a factor the greatest number of times it appears in either one. So n plus 1 appears twice, all right? They both have n plus 1 as a factor, but this one over here, this expression, needs 2 of them. So we need an n plus 1 and we need 2 of them in the LCM. Okay, our denominator is going to need at least 2 of these. Then over here, it also needs an n plus 4. Okay, this one doesn't have it, but that's okay. This one has to have at least one n plus 4 for it to be a common denominator, for it to be a lowest common multiple. So there's your n plus 4. And this one only needs 1, but that's fine. It's already covered, right? This one's got 2, so this one's got it covered. All right. So you need the largest number. 2 of these. Okay, we got to put 2 of these in here. We need 1 extra of these. We stick that in there. It's just kind of thinking about building it from the components, from the factors of your 2 denominators, your 2 expressions. All right, let's try it. All right. Oh, I know it looks like so much. Just trust me, I'm going to walk you through it. I'm going to get my little pink highlighter and we'll walk through it. Okay, let's put all this stuff we just talked about together. 3t plus 2 over t squared minus 2t minus 3 plus t plus 1 over t minus 3. This is your original expression right here. Okay, this is our original problem. Okay, in the pink. Sweet. Well, we know that we don't know what, we have to break this down because we don't know if this is a factor of this or what. Like we have to get a common denominator. So we've got to break this down. And how do you break down a polynomial? You factor. So factoring this out, and you can just trust me that I factored it out correctly in this one, or you can do it yourself, you know, make your little diamond or your X and go ahead and factor it out, but it is going to factor out, thankfully, to t minus 3 times t plus 1. Notice my numerator is the same, and this expression is unchanged, right? All I did from this pink section over there to this section here, all I did, the only thing I did is factor. Now, I'm looking here and I'm saying, what is my common denominator? What is my lowest common multiple of this t minus 3 times t plus 1 and t minus 3? Okay, we need to create an expression that has, well, they both have a t minus 3 in it, right? So, okay, our LCM's got to have a t minus 3. And that's all this one needs for it to be included. And this one also needs a t plus 1. Okay, so this needs a t minus 3 times t plus 1. Cool. This denominator, it's nice. It's actually already made for us. It's gonna be our common denominator. It works for this because that is a factor of that, okay? That's sort of like when you would have something that's like 1/2 plus 1/4, and you're like, sweet, I don't have to change the 1/4. This is kind of a situation like that. This is your 1/4. You don't have to change it, right? This will fit into it. So what you do have to do when you have a situation like 1/2 and 1/4, though, is you do have to find a common denominator, and you have to turn the halves into fourths, and you have to say, what do you need to do to the 2 to turn it into a 4? Well, you multiply it by 2 over 2, right? The same idea applies. It's the same exact idea. What do we have to do to t minus 3 to turn it into t minus 3 times t plus 1? Well, you have to multiply it by t plus 1 over t plus 1, because like I said, that blue text equals 1. Anything over itself is 1, right? It's the same thing you would do if you had 2 over 2. You're just the exact same idea, right? 2 over 2 instead of 2 over 2 is just t plus 1 over t plus 1. All right, so now we have this expression, and I'm just going to combine it here. Look at this. We've got this expression moves right down here. We can keep it just the same. That's why I have that big old arrow there. 3t plus 2 over t minus 3 plus t plus 1 plus, okay. Notice I simplified the numerator. You're like, where did this t squared plus 2t plus 1 come from? Well, back here, we had to do a little work because remember, that made the denominator. Now we have to do the numerator, right? 2 times 2 would be 4. But our numerator is 2, now it's 2/4 now. It's not 1/2, it's 2/4. You have to multiply your numerators too, and here we go, we're multiplying our numerators. So I FOILed this out, t times t, t squared, 1t, 2t's, 1 times 1 is 1. So I FOILed that out, Okay, first outside, inside, last. You should know what FOIL is by now, so I'm not going to go in depth into that. Let me erase this because it's getting a little bit cluttered. All right, so the reason that this now looks different from this is because we did multiply these two out. I did not leave it in factored form. I simplified it, right? Meaning I used FOIL and I simplified it, and I did that for a reason. Okay, I did that because it's easier to add. Because now our denominators are the same, we can just put it over one denominator that we decided was good, right? Our denominators are the same. And now we need to combine the like terms of these two expressions. So no t squareds over here, so t squared stays the same, right? You keep your t squared. And then 2t and 3t become 5t. They're both positive, we're adding, so plus 5t. Okay, and then 2 plus 1 is plus 3, plus 3, right? And we're done. I did a lot of explaining in the middle. As you do these on your own, it's gonna be a faster process because you're not gonna have me yakking at you. Okay, I did it because it makes it easier to combine the terms to get the final answer. I left the denominator in factored form, it's fine for me. Your teacher's mileage may vary. Most teachers just let you keep the denominator in factored form. They don't make you take the extra step to simplify it. But if your teacher wants you to, then obviously do what they say. You want your full creds. All right. Moving out of this, and we're gonna give it a try. All right, everybody breathe. Ready? Here we go. Yes, I love it. All right. Unlike denominators, we have to find a common denominator. So what's the common denominator between b and b plus 1? There's no common denominator between b and b plus 1. This side, this situation is kind of like having like a 1/5 plus 1/3 situation. Like there's no one going into the other, like you just have to multiply them to each other, right? The LCM of this is gonna be 15. You're gonna have to do 5, and this side you're gonna have to go times, 3 over 3, and this one's gonna be 5 over 5, right? That's what we're gonna have to do in this situation. Okay, so let's get to it then. Let's not waste any more time. We know that this side is gonna get multiplied by b plus 1 over b plus 1. And this one's gonna have to be multiplied by b over b. That's a b, all right? So what does that turn all of this into? Well, first of all, we know our common denominator is gonna be b times b plus 1, right? b times b plus 1. We know that's gonna happen. That's happening. So then we go up here, and now we have to FOIL, okay? b times b squared, b times 3 plus 3b, 1 times b plus b, 1 times 3 plus 3, and we keep going because this is adding. Now we have b times b plus b squared, and b times -5 minus 5b. Whew, put it all together. Now, if this had been a minus sign, like down here, you're gonna have to be a little bit more careful, right? Because we're gonna have to distribute that negative sign. But right now, we don't have to worry about that yet. We'll get there. All right, here we go. All of this, all we have to do is combine our like terms now. Here's our denominator, b over b plus 1. And then in our numerator, we've got 2b squared. And then we've got positive 3b and negative 5b. I'm gonna cross these off because I did them already. I got this one, I got this one. 3b and negative 5b is gonna be negative 2b. Oh, but we got plus b. Oh, is that 5b? That doesn't make sense. What did I do? It's not 5b, never mind. What on earth am I doing? Let me erase that. Yes, no, minus 5b, that's right. Yes, I'm not crazy. For some reason, my brain was like, we're foiling these. No, there's not a 15 in there. All right, so there's another b here. So it's gonna be just negative b minus b. Okay, and then we have 3. Yep, plus 3. There you go. Now you can, of course, check to see if you factored this, if it would need to be simplified. I mean, I guess we could check really fast and see if it needs to be simplified. And 2 times 3 is 6. And then negative 1. 2 and 3, yeah, looks like it might be able to be. And it would be negative 3. And then because it has a leading coefficient, you'd actually have to factor it a little differently than I've been showing you. If you're in my class, you probably recognize this method. Some of you might do it differently with your teachers. That's okay, you do it your own way. So we've got 2b squared minus 2b, oh, no, plus 2b minus 3b plus 3, and then I group it and factor out a 2b times b plus 1. Oh yeah, look at that. We are going to have to do this 2b times b plus 1, and then this is going to be, you're going to factor out a negative 3, and then that's going to be, oh no, just factor out a 3 plus 3. No, that's going to be negative b is plus 3, yeah. So if we take out the negative 3, then it becomes positive b, but it becomes negative 1, b plus 1, and b minus 1. So I don't think we are able to factor these like these. Checking my work here. It's always great on like a one take where you can't edit this part out. Feel free to skip ahead. I'm gonna pull out a 3. That's still negative b. Yeah, okay. So it's not quite gonna work. All right, so there's your answer. Can't quite work. Can't quite make it work. Or maybe I will see it and I'll wake up in the middle of the night and go, yes, you can. But for now, we got to here. All right, this is the important part right here. So finding your common denominator, remembering to multiply your numerators. Stick your numerator in a big long run if it helps you. If not, keep it in 2 separate ones, whatever makes your day happier. I like to put mine all in one bar. And there you go. All right, let's look down here. X and 8x. Okay, this is a little easier situation. This one, obviously, we're just going to need to get a common denominator. Our common denominator is going to be 8x. So we just need to multiply this side by 8 over 8. Easy enough. All right. So now we've got 8x as our denominator. And over here, we've got 3 times 8 is 24. And don't forget to distribute this negative sign. Negative 5x plus 2. Okay, simplifying that, we've got negative 5x plus 26 over 8x, and there's nothing else we can simplify there. Can't factor anything out of this top one to check it, and it's just, that's what it is. Okay, not too bad. All right. Going on to the next lesson next time. All right, so now we're going to learn about mixed expressions in the next video, and I hope that this was helpful for everybody.